let's go to page 87 and let's do number 131. Okay, it says show that if the expression 21x squared plus ax plus 21 can be factored into two linear prime binomial factors with integer coefficient, then a must be even. Okay, so if you do the master product to do the factoring, so the middle number is a, and the master product would be 21 times 20 would be 441. Okay, and so if you find all the factors, you're going to have 1, 441. 2 is not going to work, so 3 give you 147, and 7 will give you 63, and 9 will give you 49, 21 give you 21, and so right now just a reversal, so 49, you get 9, 63, 7, and 147, 3, 4, 4, 1, 1. So no matter what the a is, notice all these are odds. Okay, so when you factor into two parts, okay, so you're always going to get odds. So you're going to have the odd solution. Okay, from here you're going to get odd and plus odd. Okay, so in other words, a is going to always odd plus odd. So you're going to all the answer would be odds. Okay, and therefore, because a is r plus r, so a must be even. Okay. Again, from here, right? Again, from all the list, all the possibility of the factors, no matter which combination it is, a must be even from these. Okay. So again, it's always r plus odd, so a must be even. Okay. Okay. Let's go to number 132. You're looking for the square root of 53 minus 8 square root of 15. Okay, so this one we need to go and set it into two different parts. But remember, square root of 15, you can break into square root of 1 times square root of 15. But usually that's less chance of having that happen. More likely, you're going to have the square root of 3 and square root of 5. And so we're going to try that first. So set it equal to a square root of 3 plus b square root of 5. Okay, so you can do 3, 5 or 1, 15. Okay, but most of the time it's going to be 3, 15 usually. Okay, so let's go and try that first. If it doesn't work, then you have to try 1 square root of 1 square root of 15. Okay, okay. So once you do that, go and square both sides, and so this will cancel out. So you got 53 minus 8 square root of 15 equal to. So you square this, you're going to get 3a squared. You square this, you're going to get 5b squared. And the middle term would be plus 2ab square root of 15. Okay, so you can square this, you get that. Square this, you get that. And middle term times all this together, you get that. So now we're going to do the matching. Okay, so matching the integer part with the integer part. So you get 3a squared plus 5b squared equal to 53, and then this part equal to that, so 2ab squared of 15 equal to 8, negative, watch out for the sign, so negative 8 squared of 15. So divide by 2 squared of 15, so you got ab equal to negative 4. Okay, so now let's go and try different possibilities. So make a table. So you got a, b. So to get negative 4, you can have 1, negative 4, 2, negative 2, and 4, negative 1. And then you can do the reversal. So you can have negative 1, 4, negative 2, 2, negative 4, 1. Okay, so now you have to check each one. Put this into here and see if it works. Okay, so you got... So 1 squared times 3 is 3 plus, so 16 times 5 will give you 80. So this is too high, so it's no good. Okay. Now try 2. So 2 squared is 4. 4 times 5 is 20. Okay, let's put on the side. And 2 squared is 4 times 3 is 12. So you're going to give you, so you're going to end up with 32, so it's no good. Okay. Okay, now let's try this one here. Okay, 4, negative 1. So 4 squared is 16 times 3 is 48 plus 5. So this one works. So this one no good, no good. And this one it seems to, so put negative 4 over here. So this one seems to work, but if you put back in the original, it's not going to work. Okay, the reason for that is because if you put over here, so if you write it down first, so this one you're going to get 4 square root of 3 plus minus. So right now you seem to have 2 candidates, right? So you're going to get 4 square root of 3, and you're going to be minus square root of 5. So that's one answer. The other one would be negative 4 square root of 3 plus square root of 5. Okay. Now you have to check your original. See, when you have square root of something, you have to be a positive number. So with this one, this is about 2.2. This is about 1.7. So it's going to give you a negative value. So this is not going to work because again, square root. If this square root of number is not going to be equal to negative, and so this will give you a negative value. So this one is no good. Okay. So only answer is good is this one. So you can always check. Okay. So once you get your candidates, write it down and you check each one, see if it's reasonable. Okay. Okay. Let's go to 133. Okay, so you find all the z's for 9 to the z minus 1 minus 3 to the z minus 1 minus 2 equal to 0. Okay, so what you want to do is you want to change this into base 3. So you're going to get 3 squared to the times to the z to the minus 1 minus 3 to the z minus 1 minus 2 equal to 0. And over here you can see this when you have the same part, okay. So notice that this is a square of that. Okay. So you have 3 to the 2 times z minus 1 minus 3 to the z minus 1 minus 2 equal to 0. So this is the exponent is twice as that means this is a square of that. So that means this is a quadratic form. So you want to let z, z is already used. So let's go and use different variable. You can use any variable. You can let a equal to 3 to the z minus 1. Okay. So this becomes a squared minus 3a minus 2 equal to 0. So let's go and do the solving. So you got negative 3, negative 2. Oh, wait. This is just a. Yeah, to be careful. So this whole thing is a. Okay, so it's negative 1. So you get 1, negative 2. So you got a and a. So it'd be plus 1 minus 2. So you got a equal to negative 1, a equal to 2, and you put it back. So you're going to get 3 to the z minus 1 equal to negative 1, 3 to the z minus 1 equal to 2. Okay, so from here, 3 to the exponent equal to negative 1. This is no good. Okay. Now this one over here, you can use you can go and this one you can go and use the change of base. So if you change your base, So you're going to get log 3 and switch, right? So you're going to get 2 equal to z minus 1. And plus 1 on each side. So you got 1 plus log 3 base, log 2 base 3 equal to z. Now you can combine these because the 1 equal to log 3 of base 3. And when you're adding two logs, you can multiply the inside, so you got log of 6 base 3 equal to z. Let's go to 134. Okay, you have the quadratic formula ax squared plus bx plus c. And without using quadratic formula, show that the sum of the roots is negative b over a and the product of the roots is c over a. Okay, so first what you need to do is to find roots, you have to set equal to 0, and then to apply the root equation, you need to go and get rid of the a, so divide everything by a. So x squared plus b over a, x plus c over a equal to 0. And then you apply the root equation. So from here you can see the R1 plus R2, the sum of the roots equal to negative b over a. And the product R1, R2 equal to c over a. Okay. Let's go to number 135. It says what quadratic polynomial with 1 as a coefficient of x squared has the roots, which are complete conjugate of the solution of this one over here, of the x squared minus 6x plus 11 equal to 2xi minus 10i. Okay, so you got x squared minus 6x plus 11 equal to 2xi minus 10i. So first I'm going to move everything to one side. So I get x squared minus 6x plus, so move this over. So it'd be minus. So move this over, so get minus 2xi. And then plus 11 plus 10i equal to 0. And then you go and do the grouping, so minus, so you got 6 plus 2i x plus 11 plus 10i equal to 0. Okay, and then after that, you can apply so from here the roots. So the R1 plus R2 equal to 6 plus 2i, and R1, R2 equal to 10 plus 11 plus 10i. Okay. And then after that, you want to do the conjugate. So for the conjugate, you're going to get R1 plus R2 equal to 6 minus 2i. And over here, R1, R2 equal to 11 minus 10i. Okay. And so from here, you go and put it back. So you got x squared minus 6 minus 2i x plus 10 minus 10, 11 minus 10i equal to 0. And that's it. That's what I asked for. Okay. Okay, let's go to 136. You want to evaluate square root of 10 minus 4i square root of 6. Okay, so even though you have an I, you do the same thing as the radical equation. So you want to set it equal to, again, there are different combinations, so you kind of have to try it out. Okay, so you're going to have a square root of 3 plus b square root of 2i. Now this one has more combinations, so you have to try each one because you don't know which radical go with I. So you have to try, so there are different possibilities. You can have the square root of 1, square root of 6i. Then you can have a square root of 2, square root of 3, 6i. Then you can have a square root of 3, square root of 2i. Then you can have square root of 6, square root of 1i. So all those combinations. So you have to try them out, okay? So again, so after you try each one of that, go down the list. So then again, just go and try those, okay? And so this is the one that's going to work, okay? Okay, so again, you have to try each one of those. If it doesn't work, you try the next one. So again, you can do the square root of 1, square root of 6i, square root of 2, square root of 3i. Then you can have the square root of 3, square root of 2i. Then you can have the square root of 6, square root of 1i. So you got different combinations. So you have to try each one to see which one work, okay? So anyway, so this is the one that's going to work. So go and set that, and then you have to square both sides. So you're going to get 10 minus 4. I'm going to put an I in the back. Equal to, square this one, you're going to get 3a squared. Square this side, now you have to be careful. So you're going to get minus, so I squared is minus, and you're going to get 2b squared. The middle term is going to be plus 2ab squared of 6i. So multiply all this together, you get that. Okay, so now all you have to do is matching. So you got 3a squared minus 2b squared equal to 10. And you got 2ab squared of 6i equal to negative 4 squared of 6i. So the 6i cancels out and divide by 2. So ab equal to negative 2. Okay, so now again make a table. So AB, and you can try 1, negative 2, 2, negative 1, and you can have negative 1, 2, negative 2, 1. Okay, so let's go and look for the possible candidates. Okay, so you put 1 in here, so you're going to get 3 minus 8. It's not going to work. So try this one. 2 squared is 4 times 3 is 12. 12 minus 2. So this is going to work. Okay, and try next one. Again, this doesn't work already, and this works. Okay, so these are two candidates. So let's go and put it in there. So 2 minus 1. So it'd be 2 squared root of 3 minus square root of 2i. So that's one candidate. And this one over here. So you're going to get negative 2 squared root of 3 plus square root of 2i. Now because of the I, because this is imaginary, so even if it's negative, it's gonna be okay. So both of these are okay. Okay, let's go to number 137. So you got a plus b over a is equal to b over a plus b. And you want to show that a and b cannot both be real. Okay. Well, first let's go and cross multiply. So you're going to get a squared plus 2ab plus b squared equal to ab. So cross multiply, and then make it equal to 0. So minus ab on both sides. So you got a squared plus ab plus b squared equal to 0. And you apply the quadratic formula. So a equal to negative b Okay. So quadratic form is a equal to negative b plus or minus square root of b squared minus 4ac over 2a. So that's your formula, right? So so you have to think of this way, okay? So think of a is your variable. So the coefficient for this would be the b, okay? Now, now a is the coefficient of the variable, so it would be 1, and c is the number over here, so it would be b squared over 2 times 1. Okay, so a equal to negative b plus or minus square root of, when you do this, you're going to get negative 3b squared over 2. Okay. And again, from here, that both a and b cannot be both real. So if b is real number, then this will give you imaginary. So again, if b is real, then a cannot be real number. You have to be imaginary. Okay. So from here, you can see that a and b cannot both be real. Okay. So again, if b is real, then a would be imaginary. So cannot both be real numbers.